Hello, welcome to the second episode of our presentation on how to use the graph calculator. In the first video, I have mentioned that we can use this software when we want to check on the graph of some functions or relations, especially if we are preparing for materials for our student. I am Nixiban and I am a mathematics educator. In this presentation, I'm going to show you the syntax for graphing some of the other functions that we have. We are going to start with our trigonometric function. There are basically 6 trigonometric functions. I'm going to show you in detail the first 3 and then quickly the other 2. So for our trigonometric function, we have the following syntax. For the sine function, we simply have to encode sine and then enclose the variable, the independent variable x with a parenthesis. That's the same for the cosine, the tangent, and then the reciprocal functions such as the secant function, the cosecant function, and the cotangent function. Let us graph them all in one Cartesian plane. So let's add a function using this button. Encode sine, open parenthesis, x, close parenthesis. We may want to vary the colors here, so we can do this one, or limit the graph of the function that we show by using argument range. Okay, let's click this one. It will give us a function for that sine function. Of course, the most general form of a sine function is y equal to a sine b x plus c plus d. So the graph that we see here is just the most basic one. So we can graph this one. A, B, C, and D here are any real numbers. Let's add another one. How about a cosine function this time? So I'd like it to be 3 cos 4x. How does it look like? I want another color. I want it red, maybe. If there's an error here, comparison operator misplaced because we put equal sign. There should be no equal sign there. Just straightforward because we already have the equal sign there. So that's the graph of the cosine function. So it's really busy right now. So we may want to limit the graph that we will show. So anyway, in our axis, we forgot this one. We want to show the graph on angles in radian. So we want to check this one in our axis. So show as a multiple of pi. Right. So we notice now that the numbers on our x-axis are angles on radians. How about a tangent function? Say tan of x. How does it look like? Let's use another color other than red. Blue. Let's use blue. So there we have it. We may change the name of our legend just to be more consistent because they are not all f of x. So maybe you want to name them with different names, such as maybe for the cosine function, we name that as g of x. And for the tangent function, we name it as h of x. There we have it, the graph of the 3 trigonometric functions. It's actually, the idea is actually the same for the remaining trigonometric functions. So I think it's very simple. I do not have to do it here. Alright, remember, in a trigonometric function, the term here, the coefficient that we use as a, gives us the amplitude. I am saying this because I don't want you to be confused on our next batch of functions. They are our inverse trigonometric functions. The syntax for inputting the trigonometric functions is this one. So if you notice, it's all the same with our trigonometric functions. except for that letter A. Letter A is actually a command. It would tell the graph calculator that you are graphing, you want to graph a inverse trigonometric function. So we are not referring to the amplitude here. This is a command to tell the graph calculator that it is an inverse trigonometric function. So let's do that. Let's leave the first graph, the sine graph. Let's graph an inverse trigonometric function starting with the inverse sign. So we have a sine, I do it into the a sine x. Let's have this as blue. So there we have it, the graph of the inverse sine, inverse trigonometric function. We do the same for the rest of the inverse trigonometric function. Why can we see this graph only? Because we are assuming that we are graphing a function. So this button here, we can only graph a function, not a general relation. So for example, you cannot graph a circle using this button. So alright, those are our trigonometric functions. What else can we graph here? There are other functions that we can graph. Let's check our task here. So aside from our trigonometric functions, we also have our radical function, the power function, and the logarithmic function. So let's just have a review on our radical functions. So the basic radical function is this one. We have y equal to square root of x. A more general form, we have the nth root of square root of x. So the green functions here, the green equations here are the definition of the function. The blue ones, that's how we input it in the graph calculator. So for example, SQRT, square root of x, it will graph square root of x. If we input root, open parenthesis, n, comma, x, so n could be any number greater than or equal to 2, because this is the index of the radical function. Or we can actually use its exponential form. We can have x raised to 1 over n. It would give us the graph of the radical functions. For power functions, exponential functions, we have a raised to x as the general form. In graph, we simply use this symbol to mean power. Natural logarithms, this is log x. It's just the same, log x. Also, for the common logarithm, we have log x. This means that the base is 10. Yes, it's just the same if we write it in the graph calculator, log of x. The general logarithmic function, we have logarithm of x to the base b. How should we write this one? We use log b x and then comma b. Let us graph some examples of this one. So let me uncheck this one so it won't show in our graph. Let us graph a square root function. So the very first one, square root of x. So there we have it. I want to put some restriction here. I want to put an arrowhead. So let me start from, for 0, that's the starting point. The domain of the square root function starts from 0. I want to end here, at least in the graph only. I want to show the graph until, say, 5, and then put arrowhead. So I want to emphasize that it starts from 0, so I can click it here. And I want to change my numbers on my x-axis because we are not referring already to angles. That's only true to trigonometric functions. So there we have it. We're back with our numbers. It's a function whose domain starts from 0, infinity, to infinity again. How about if we want to graph a function, a square root function, whose index is higher than 2? For example, cube root, the cube root of x. That's the function that we want to graph. So our command should be root and then the index, that's 3, and then our independent variable x. So that's the graph of cube root of x. Let me change the color, put it a little to the right, and restrict it from -2 to positive. Arrowheads, I forgot the arrowheads. There we have it. If we want to graph 10th root, for example, of x, that's really easy. It's the same root, the index that we want, that's 10, and then the variable x. So there we have it. Let's change the color to red. We want to show from 0 to 5. This is a shaded bullet and then an arrowhead. So there we have it, the three root functions. And now we are done with the root functions. Let's have exponential functions. Let's start with the very basic one, a raised to x. This is our general exponential function. So of course, a here is an element of the real numbers greater than 0, but a is greater than 0, not equal to 1. If you set this one as 1, so we have a raised to 1 raised to x, y equals 1 raised to x. This is not already an exponential function because 1 raised to a number is a constant. So let us try to graph y equal to 2 raised to x. So the value of a is, so we have 2 raised to x. How does it look like? There we have it. This is the graph of 2 raised to x. What else? We can actually make the value of a equal to e, Euler's constant. And that's the graph. It's similar, but not entirely the same. There we have it. We can put arrowheads and change the labels if we want. What else do we have to graph here? Logarithmic functions also. Logarithmic functions. Let us graph ln of x. So it's just the same, ln, and then enclose x with a pair of parentheses. So there we have it, the graph for logarithmic, or I mean the graph for the natural logarithm. How about the common logarithm? That's simply log of x, and that's the graph of the basic common logarithmic function. And then how about if we want to graph a general one? So the base is not the Euler's constant nor 10. So we want other base. The command is log b x comma b. So it's this one. We do not actually change b here. It's part of the command. We only change the second b, the b that is included in the parentheses. So log b x comma, and then the base that we want. So maybe we want 3. It will give us another graph. So these are families. These graphs belong to a family of logarithmic functions. Let's try to just to differentiate the 3 logarithmic functions. So I hope you know your logarithms. Of course, the natural logarithm is just the same as this one, except that the base is set to the number, the constant e. So that's the natural logarithm. The common logarithm means that the base is set to n. So the third function here is the most general one. We can change the base to any base that we 1. So of course, if we change, so using this command, if we change this to 10, of course it will be the same with log x, the common logarithm. So they will overlap. It's just the same. Or if we change that to e, it will be the same as our natural logarithm. So it will overlap the graphs because they are just the same graph. Right. There we have it. Graphing the different types of functions other than polynomial and rational, since we presented that as we presented in the first video. I will show you the last set of functions that I'm going to show you are a bit special because they are neither of the functions that we have presented. So let's start with what do we have here? The absolute value function. The function, the most basic absolute value function is this function, y equal to the absolute value of x. The syntax for the graph calculator to interpret the absolute value function is ABS of x. So let's do that later. What do we have here? What else do we have here? We have the step functions. Step functions, there are two step functions, the ceiling function and the floor function. What is the ceiling function? The ceiling function is otherwise called the least integer function, and this function is a function that gives back the least integer that is greater than or equal to x. The greater integer function or the floor function is a function that gives back the greatest integer that is less than or equal to the number x. So for example, the symbol that we are using is this one. So for example, we are looking for the floor value of 8.7. It is referring to the integer that is the greatest integer that is less than 8.7. So that is. But if we are looking at the ceiling value of 8.7, we are looking for that least integer that is greater than 8.7. So that is our ceiling function, and that is what we want to graph here. Maybe we want to memorize the command, or I mean the syntax for the graph calculator to interpret the step functions. We have CEIF for the ceiling function of x, and then floor, literally floor for the floor function. Absolute value function, we have ABS of abs. For our last special function that we have here, it's the probability density function of a normal distribution. For our friends from the statistics department, they know this one. The probability density function is given by this expression here. We have 1 over sigma squared of 2 pi e raised to negative the square of x minus mu all over 2 sigma squared. But we do not have to input this equation here because we have a shortcut in our graph calculator. So we simply have to encode d norm. So this means normal distribution. The parameters that we need there is x, the mean for our normal distribution, and the standard deviation. For a standard normal distribution, if we recall, just a recall, the mean is set to 0 and the standard deviation is set to 1. If you are graphing a standard normal distribution, but if you're graphing any other normal distribution, meaning the mean in the standard deviation is other than 0 and 1, then we can do that. We can simply change it here. For now, I'm going to show you the graph of the standard normal distribution. So we want to click on our add function button, d norm, that's our syntax, and then we start with our independent variable, the mean that we want. So we want it 0 because we are trying to graph the standard, as I have said, the standard normal distribution, and then the standard deviation is 1. Alright, so there we have it, the graph of a standard normal distribution. If we want to change the mean from 0 to any other number, say 2, the mean is 2, Actually, it's the same graph, only that it is transformed, it's translated to the right side. That means that changing the mean from 0 higher or lower, it would simply change the graph of the normal distribution, the standard normal distribution, from left to right. So it's only translated horizontally. If we want to change the standard deviation from 1 to maybe a higher number, say 2, let's see what happens. It's still, it looks like the normal distribution, but the the dispersion is different because we made the standard deviation higher. Remember that the standard deviation tells the dispersion of a data set. So if you increase this value, the graph will look like that. So it will include a higher range of numbers in our x-axis. If we decrease it, say from 1, we want it 0.5, it gives us a taller normal distribution graph. Alright, that ends our second episode on using the graph calculator. I will see you in another video for another presentation. This presentation, the next presentation, we will be talking about how to graph not a function but a relation. I will see you there.